Okay, everybody, let's get started again. And on the last video, we did some stuff. We did the rules, so we pretty much got all the rules laid down. And at this point, it would be nice to just get back to the book to sort of just gather my flock. Now, there is one little thing. I've told you that you can, and indeed you can. I've not told any lies or made any mistakes. I've told you that you can raise things to irrational powers and fractional powers, but I've not really told you what that means. Like, I've not really told you what the 1/3 power means, and but it's not hard to figure out. Now, the irrational power is a little harder to explain, but I'll show you what rational powers mean when they're not integers, that is. Well, we already know negative powers are reciprocals, but if we have things like rational powers, how do we deal with that? So, like if you have 8 to the power of 1/3, excuse me, I meant 1/3. Come on down the page here. So 8 to the power of 1/3. That would be, we define that to be the following. The 1/3 power, the bottom indicates what radical we're taking, what root we're taking. So 8 to the 1/3 power equals the cube root. So I'm going to go to equation tools. Well, that's not nice. It didn't let me, did it? So, it's already got them up here. So let me go to equation tools, and let me blow the screen back up. Equation tools, insert, equation, just a minute, sorry. Insert, equation tools, hold on, well, I can't find the cube root. I don't want to start the video over. That'd be a drag. I'm 2 minutes in. I may have to. Let me see. Where's cube root? Well, but the 8 to the 1/3 power is a cube root. And if I'm trying to minimize it, and I'm trying to, why has it been so, it's kind of been nasty right now. Well, it's just been nasty all over. Let me go down and open up a new Word file. It may just be a faulty Word file. I don't really have time for this. All right. So let me go to home. Let me go to home. I'm losing minutes here. Let me go to 24. I'm going to insert. Let me go to equation. And equation tools. And that beats all. This video may be shot. Insert. Equation. Symbols, maybe? It usually shows it up here. Huh. I may have to go to ink equation. Yeah, here's ink equation. But I usually don't have to do this. So if I do the cube root of 8, let me insert that in. So there's the cube root of 8. And there shouldn't be a dot there. That's okay. Go away. So that's the cube root of 8. And of course that's 2, right? I don't know why. Usually there's a palette. But so let me go to insert again. Equation. And it's kind of making me mad today. But let's do 8 to the power of 2/3. And put parentheses, automatically put it up there. And, well, if I go to insert, and if I go to equation, and if I go to inc equation, I can go, now, the cube root of 8 to the 2/3. Now, the 3 on the bottom means that I do the cube root. So I do the cube root of, and I write my radical symbol. That 2 up top means we have 8 to the 2 inside, like that. So that's the cube root of 8 to the 2 power. Forgot my equal sign, sorry. So that's the cube root of 8 squared. And that's what that means. Now we can clean that up. Now I'm going to assume you've seen this in Algebra 2. I've got to start somewhere. But that's the cube root of 8 squared. And you might be like, oh no, that's not exactly obvious. Well, that's going to be the cube root of 64. And remember, that would be hard, but it's nice here because that's 4. The answer is 4 because 4 times 4 times 4 is 64. When you multiply 4 by itself 3 times, aka when you cube 4. And let me just put because, I never spell it, 4 cubed equals 64. You know, like that. That's how you interpret fractional powers. And now if you do that, the analogous thing with -8, which you can do, and I should because students can't handle negative signs sometimes. You got to use the parenthesis, right? Use the parenthesis, and I'll have to unfortunately make my font smaller. I don't really want to, but have to. So I'll come in here and I'll make this -8. Now sometimes you'll get a different answer, sometimes you won't. It just depends. If the numerator is even, you'll get the same thing. And 2 is even in lowest terms, assuming lowest terms, and 2 is even. So what happens is we still get 64 in here and we get the same thing. Okay. Now, if you'll end up, now I'll tell you when you won't get the same thing. Like if you have, let me hit Control V again. Now let's try something new. Let's do 25 to the, could I do 3/2? Or I don't want to get everybody mixed up here. Yeah, I may have to do 3/2. 25 to the 3/2. Now this time, that's the square root, right? Now square root has an understood 2 out here, right? So unfortunately, tradition has it that we just leave it barren like that, but there really is that understood 2 out there. So the bottom 2 is understood to be here. Now we put 25 cubed in here. Now, yeah, we could go ahead and do 25 cubed. That's all fine and dandy, but that's kind of nasty. Let's see if we can get this cleaned up a little better. So, well, 25 cubed, so it's the square root of. Now, 25, put it in parentheses, make it 5 squared, and you'll need another layer of parentheses. And then for the cube, well, shucks. So close parentheses, cubed. Now, I meant to put that in. It needs to be in the radical. Well, actually, there's a rule that says I can take it out here, right? But I want to put it in the radical so it'd be pretty. How about I do this? And then cubed like that, close off there. Yeah. Now, so that's what I want to write. So here's the thing. No. Sorry. I meant to make a 3 there. I didn't mean to do that. The 2 is in the 2 is on the index. Yikes. But well, yikes. No, I didn't mean to do that. So 25 is 5 squared. And then the 3 for the cube goes out here. I'm turning 25 into 5 squared, right? And yeah, that's right. So 25 is 5 squared in parentheses, the important parentheses there, and then close off cubed. But remember from the MN rules that we did earlier, we multiply that 2 and 3 and get 6. And, well, here's the thing. That's the same thing as 5 to the power of who? 6 over that understood 2, right? Going backwards, I'm taking it backwards. That's 5 cubed. That's 125 down here, and it broke my line and went down here, unfortunately. So it's 125 down here, right? But yeah, that was kind of a long highway. But if you wanted to make it a little shorter and sweeter, what you could do is just immediately take the square root of 25, which is 5, and then just do 5 cubed from there and get 125. But I wanted to show you how it works, right? Show you all the rules and the laws. You can, and indeed you can go backwards, 5 to the 6 over 2, and that'll give you 125. But if it feels like I cheated when I did that, I didn't cheat. But if you want to do it the hard, rigorous way, here's what you can do. You can proceed as follows. Well, the square root, you can do the square root of 5 to the 6th power. That gets ugly, right? But here's the thing. You're doing the square root of, well, you got a 5 times 5, and I'll need to skip a line. I got 4 minutes left. And all this is inside the radical. 5 to the 6th power by associativity and all that, you got can be written as, 5 times 3 power of 5 times 5. And by the laws of algebra that you learned in Algebra 2, each pair comes out as a single 5. So you got 5 times 5 times 5, which is 5 cubed, which is 125. And I skip yet another line. So we got 125 down here. You can do it that way as well. Either way, just whatever, whichever way you like best. But I just want you to see the connection. And if you want to make it real short and real sweet, what you could do is I'll copy, I'll paste, and just say, look, do the square root of 25, which is 5, cube the 5, get 125. That's real short and real sweet. But I wanted to show you where everything came from, and I'm down to my last 2.5 minutes. Lost a lot of time on techno, but next video I'll try to make that better. But now let me show you. I said negative would be different on this one, didn't I? And I've got 2.5 minutes to make my claim. Since we got a negative, we'll need parentheses, right? And we can't do negative here. This is undefined. Uh-oh. Actually, it's not only different, it'd be an imaginary number. It's undefined for now, right? I don't want to do I don't want to use imaginary complex numbers right now. Okay. So it's undefined for now. I don't want to use imaginary complex numbers. We'd have to take the square root of neg 25, which would be like 5 imaginary I, or 5 times I, and I don't want to go there right now. Those are things called imaginary numbers anyway. You can see why now imaginary numbers are more delicate. Now, if we have something like, let's do one more example. Now, if you have something just strange and convoluted, like x plus 2q raised to the 3/2 power, yes, you can interpret that as the square root of x plus 2q without, and you can do without parentheses there, but you'll need to put them, you have to put them somewhere. You can put them here, and you can cube here, or you can do the square root of, and you can put the cube in here, x plus 2q cube there, but the cube has to go somewhere, right? You can cube here or cube here, and assuming all variables are positive, right? Assuming all variables are positive, or maybe 0, right? Or 0, because we could do 0 okay here. Just not negative, though. So you could have here, or you could have here, right? You can do the bring in of the 3. Anyway, hope that helps. And one last thing I forgot to mention here is right here where my cursor is, you can notice that the square root of 25 cubed is the same thing as the cube of the square root of 25. And that's true in general for positive things like 25. Bye.